Hello, guys. Welcome back to MedZone African Motives. We are still on our grade 12 mathematics, working with the Term 1 test, the controlled tests for Term 1. So we had a March 2025 exam test that was actually written on 12 March 2025. So we're going to consider that as a revision from the Gauteng province, that is Johannesburg West District. So it was out of 50, all right, and a duration of what? 1 hour. So without wasting your time, guys, make sure you go through the instructions. Every part of instruction is important, all right, especially that our answers, they are supposed to be rounded off to two decimal places unless stated otherwise, if necessary. So for you to download the question paper, just check the comment in the comment section. You're going to see the comment that is there for you to download the question paper, or you can check the description of the video, or you can go through the drive for grade 12. All right, there's a drive. If you check the description of the channel, you can download your question papers, any subject for grade 12 that we have. All right, so like I said, guys, I'm not going to waste your time here. We are given question number 1. It was back to the algebraic equations, expressions, inequalities. So that is 1.1, solve for x. All right, 1.11, we are given, that is 1.11. Okay, let us just quickly look into this. X into x minus 2 minus 1, that is equal to minus 1. All right, they are just trying to play around with us. If we check here, there's a tricky thing. The minus 1 minus 1, this was just going to cancel if we add 1 both sides of our equation. That was going to be x into x minus 2, which is equal to what? Minus 1 plus 1, that's a 0 there. So this canceled, this canceled. So are we saying they just try to play around with us? Yes, you could have just expanded your brackets. It's fine. Then you collect the like terms. But as we can see, if we have got this, we can use the zero concept, the product of two terms to give us a 0. Either one of these must be equal to 0. So thus, x is supposed to be equal to 0, or x minus 2 is equal to 0. So that is, we are going to have x as what? Positive 2. If we add 2 both sides, that was going to give us a 2. All right, so these are the two possible values of x. X can be equal to 0, or x can be equal to what? To 2. All right, looking into the second part of our question, it was an inequality that we are given, solving for x again. All right, so let's look into our inequality. 1.12, x squared minus 5x plus 4, that is less than what? Less than 0. All right, so it was a nice inequality, as we just have to factorize first, then determine our critical values. The coefficient of x squared is 1, so this was a direct factorization. Considering the products of the constant 4, which will give us a negative 5 if we add them. Which products do we have for 4? Since it is a negative 5, so let's consider the factors or products of 4 as what? Negative values. Negative 4, negative 1. All right, there is negative 2, negative 2. All right, so those are the negatives that we have. But which one of these, when we add, we are going to obtain what? Negative 5. So that's negative 4 and what? Negative 1. Negative 4, negative 1, that's less than what? Less than 0. So from these, we can determine our critical values, which are the values of x, when we equate this to 0, just like having two brackets as before, equated to what? To 0. So x was going to be a positive 4, or x is equal to a positive 1. So those are our critical values. With the graphical presentation, where the coefficient of x squared is positive like that, our graph is going to be concave up, looking up. So meaning to say we can actually have the final part of our solutions. In that case, x1 and 4 here. Below the x-axis, that is less than 0 there, f of x, for it to be less than 0, that is below the x-axis. Since in the x-axis, y is equal to 0. So below the x-axis, this is the region that we are looking for. So our solution was going to be taken from 1 up to what? Up to 4. But take note, we do not have an equal to on our answer. So therefore, our x values were going to be greater than 1, which is our minimum value, and less than what? 4, which is our maximum value, according to the x values that we are going to have. All right, so that is it. That is how we can simply solve an inequality of this nature, of which it was just a basic revision of our grade 11 mathematics. All right, let us consider the other part of question, which is 1.2. Solve for x and y, and we are just given a single equation. All right, I did that was let me see, but it was also it's on membership, that question. It was like this, but they were asking you to calculate the value of x plus y, like find the value or determine the value of x plus y, where you had to solve for x, then you add together with y. So in our case, guys, it is not like that. It is just solve for x and y direct. All right, just direct as it is. 10 to the exponent of x times 20 to the exponent of y is equal to 50. So if we are to check, it's a single equation. That's one thing you have to be surprised to say, why is it that? It's just a single equation, but you must solve for x and y at the same time. All right, so it follows that there are two ways. It's either we can have such a condition where these can be separated, but in our case, that is impossible for us to separate. So let us try to rewrite each term as a product of its prime vectors, these bases that we have, as a product of their prime factors, prime numbers. All right, so 10, guys, is just direct. 2 into 10, 5, 5, 1. So 10 can be written as 2 times 5. 2 times 5 to the exponent of x times the 20. We just need to have a 20, we're just going to need another 2 there. So it's 2 times 2 times what? Times 5, which is 2 squared times 5. All right, 2 times 2, that is 2 squared times what? Times 5 to the exponent of y. So this is equal to 50. 50 as a product of its prime vectors, the same if we are to consider 2 into 50, that's 25. 5, that's 5. 5, that's 1. So it's 2 times what? 5 squared. So that was going to be 2 times 5 times 5, that's what? 5 squared. All right, so there's no need for a bracket as we do not have x or y there. All right, so I want us to consider this. If you check properly, you are going to see that, or to notice that there is a 2, a 2, a 2. There is a 5, a 5, a 5. So let us separate those. The 2 on the left-hand side, the 5 on the left-hand side again. All right, so with them, these two terms raised to the exponent of x is just like ab to the exponent of n. Each term will be raised to the exponent of n. So that is 2 will be raised to the exponent of x. 5 is going to be raised to the exponent of x again. The same thing on this part. This is a product. So we're just going to raise this to the exponent of y. So it's 2 to the exponent of what? 2y times 5 also raised to the exponent of y. So this is equal to 2 times what? 5 squared. All right, no problem. The left-hand side, we have a 2 and a 2 here, same base. A 5 and a 5 here, same base again. So remember the concept on multiplication, same bases. You are multiplying same bases, you add the exponents a plus b. So for 2, we are going to consider that we are going to add our exponents for the base of 2 here. That is, if we add our exponents, it is going to be 2 to the exponent of x. The 2 here is what? 2y plus 2y, okay? The same thing considering the base of what? Of 5. there's a 5 here, there's a 5 here, under a multiplication. So still we are going to add our exponents. So this is 5 to the exponent of x plus what? Plus y. Okay, so this is equal to, on the right hand side, we've got 2 times 5 to the exponent of what? Of 2. So if we check, what is happening here is that since the base of 2 and base of 5 is found on both sides of our equation, there is a statement which mathematically tells us that it is the same thing for us to say 2 times, let's say 3, is equal to 2 times 3. So the moment that this is 2, this is 3, this is 2, this is 3, they are same. Like we have a 2 here, we have a 2, we have a 3, we have a 3. So there is no way that we are going to say this is 2 to the exponent of 3. Then here it is 2 to the exponent of 4. For us to have the same 2, it means also these exponents supposed to be the same. If this is x, this must be also x. If this is y, this is also supposed to be y. For us to say the left-hand side is equal to the right-hand side. So we consider those bases. If they are the same under a product, we are going to work with what? Exponents. The exponents automatically must be equal from that concept. So using that, we are going to consider the base of 2. This is what? The base of 2 on the left-hand side. That is 2 to the exponent of what? X plus 2y. On the right-hand side, this is 2 to the exponent of what? Of 1. So considering these two, that is 2 here and these 2 here, they are the same base. So automatically, these exponents must be equal. That is the condition of our question now. Automatically, those exponents supposed to be equal. So therefore, x plus 2y is equal to 1, equating the exponents. So the same thing on the base of what? Of 5. If we consider the base of 5, there's a 5 here, there's a 5 here. We do the same, meaning to say x plus y on this base of 5. The power x plus y there is equal to what? The power here is what? Is 2. So we have formed two equations from that statement or alone. From this statement that we have, the x and the x supposed to be the same, the y and the y supposed to be the same. So that's, we've got two equations, x here, equation 1, equation 2. We are to solve for x and y. So that is, we can solve both simultaneously. All right. X and x are the same. So we can make x the subject, you equate the two equations, or you can simply eliminate x because it is the same here. So if we subtract equation 1 minus equation 2, we are to eliminate what? We are to eliminate x. All right. So x minus x, that's a 0 there. All right. So that was going to give us a 0. 2y minus y, that is what? Plus y, which is equal to 1 minus 2, which is what? Negative 1. So y is equal to negative 1. 0 plus y, that's what? Y. If y is equal to negative 1, to find x, we can substitute in any one of the given equations. X plus 2y is equal to 1. So x plus 2 times the y value that we obtained, negative 1. We substitute that in place of y. That is equal to what? To 1. So that is, we can solve for x. X, 2 times minus 1, minus 2, that's equal to 1. So x is equal to what? If we add 2 both sides, that was going to give us a 3. So this is it. We have got the value of y and also the value of x. You end there. You end there. The question is not asking for any sum of the two. In other exam, they can ask you like this one. They will ask you maybe find x plus y. So you first find the values of x, the value of x and the value of y. Then using these two, you can now determine whatever statement that you are given there later on. So that is how they play around with you guys. You need to do more revision, more questions. So moving on to question 2, which was on our number patterns. And thus we are given the first three terms of what? A linear pattern. That is an arithmetic. All right, we are given this T1, T2, and what? T3. Prove that the sum of these first three terms is equal to 0. The sum. All right. If we were to add these three terms, that is the sum of the first three terms, we add T1 plus T2 plus what? T3. They are saying the sum is going to give us what? A 0. All right. Let's see. X plus 5, that is T1, plus minus x plus 5 plus minus x minus 5. These are the three terms. We add them together. So that was going to give us the sum of the first three terms, which is x plus 5 expand positive, that's negative, positive, positive, positive to negative, that's negative x, positive to negative, that's negative. All right. So if we check here properly, we were going to have x minus x, that's a 0 there. So we're going to remain with this minus x, all right? 5 minus 5, that is going to give us a 0. So you'll be left with what? Positive 5. So that is what you're going to have. And as we can see, minus x plus 5 is not equal to 0. But they said our sum is supposed to be equal to 0. So what is missing here? Because we are not obtaining what? A 0. So we need to find x. With that value of x, if we are to substitute it back, we are going to obtain what? A 0. So where can we find x? From these terms, remember they told us that they are giving us a linear pattern. So the only thing that we can use is the what? Constant difference. The difference is supposed to be the same, which is T3. T2 minus T1 is supposed to be T3 minus T2. So we can use that difference to solve or to find what? X. Let's solve for x. So our difference, T2 minus T1, that's minus x plus 5. We're going to subtract T1, x plus 5. This is equal to T3 minus T2. Our T3 is what? Minus x minus 5. So what are we going to subtract? We are going to subtract T2 minus x plus what? Plus 5. Let's solve for x as we have formed an equation from this. That is the difference is the same. So we have got an equation. Simplify the left-hand side. That is the condition. So this is it, guys. Simplifying the left-hand side, we're going to have minus x plus 5 distribute by negative. That's negative x. Negative times here, negative 5. That's equal to minus x minus 5. Minus times minus, that's a positive. Minus times that 5, that's going to be negative 5. All right. So on the left-hand side, we have got like terms, x and x. That's minus x minus x, just like minus 1 minus 1. So that's minus 2x. 5 minus 5, that was going to cancel. All right, 5 minus 5 is going to cancel. So this is equal to, on the right hand side, as we can see, we have got minus x plus x. This was going to cancel. Minus 5 minus 5, that's what? Minus 10. So guys, as we can see from this, because we are simplifying the left hand side and also the right hand side. So the right hand side, we are getting a numerical value. So this value represents our d. So in actual sense, we can say our d is equal to what? Negative 10 by just looking into this as we simplified the T3 minus T2, we got a negative 10 as a numerical value. So that's the constant difference. Anyways, here we are to solve for x. So divide by what? Negative 2 both sides. So x is equal to what? Negative, negative cancels. So x was going to give us what? Positive 5. If x is equal to positive 5, substitute it back into the sum of the first three terms. Remember, we solved it in terms of x. And we are saying for what? For x is equal to 5, the sum of the first three terms will be equal to, in place of x, we are going to put what? 5 there. So that's it. So minus 5 plus 5, that's equal to what? That's equal to 0. Exactly what we are being told to prove. We are being told to prove that the sum of the first three terms is supposed to give us what? Is supposed to give us a 0. Just like that. So we have our sum. That is the sum. So questions can be like that. They are going to ask you typical questions of this nature. Just make sure that you do more revision. All right, let's consider the other part. Which term of this linear pattern will be the first to be less than, it's an inequality that we are referring there, to be less than minus 20,000 and what, 220. Okay, so they're simply saying which of the terms that is going to be the first one to be less than what? To be less than 20,220. So Tn is supposed to be less than this. Then we solve for what? We solve for n. So how can we solve for n, guys? All right, we do not have Tn, but remember it's a linear pattern where we are dealing with an arithmetic. We do understand, sorry for that, we do understand that Tn is given from this formula, a plus n minus 1 times d. So we can simply consider that as part of our formula to find Tn first. So Tn is supposed to be taken from a plus n minus 1 times what? Times d. So are we having these? A, we do not have numerically, we have got it in terms of x. But since we have calculated our x, we can substitute it back here. Remember, we said x is equal to what? X is equal to 5. So if we put a 5 here, 5 plus 5, that's going to be a 10. So we have got A, the first term, which is what? Which is 10. N is the number of terms, which is the one to be calculated. We do not know this. Then D, remember here for x is equal to 5. If you substitute and calculate that, your D is going to be negative 10. We actually saw it here before. From what? From the left-hand side. Remember when I was explaining about the left-hand side, that's our constant difference, negative what? Negative 10. So you can use that or you can substitute, then calculate it. It's up to you. All right, so we have got everything, guys. So let's find our Tn. So A is what? 10 plus n minus 1 times d, where our d is negative 10. So if we are to expand by the negative 10, this bracket, we're going to have Tn is equal to 10. Negative 10 is going to multiply n. It's going to multiply negative 1. So it was going to be negative 10n. Negative times negative, that's a positive. So meaning to say our Tn therefore is going to be minus 10n, add 10 and 10, that was going to give us what? Positive 20. All right, so that is positive 20. So we've got minus 10n plus 20 representing our Tn. But remember, they say that Tn is supposed to be less than this. So meaning to say we have an inequality that we are going to solve. In place of Tn, substitute what you're given, minus 10n plus what? Plus 20. It must be less than what? Minus 20,220. We can solve this one, all right? Let's get rid of the 20. Simply subtract this one. Subtract it both sides of your equation. That was going to be negative 10. N is less than minus 20 it's going to be 240 there. All right. Then to find n, we are going to divide by what? Negative 10. Negative 10. By dividing by this negative 10, remember what happens to the inequality, because you have used a negative. The inequality sign is going to change because you divided by what? A negative. So this here changes. So it's going to be a greater than this time, all right? Negative, negative cancels. Divide here is going to be 2,000 and what? 2,000 and what? 24. So n is supposed to be greater than 2024. So meaning to say the first whole number, because we're talking about number of terms. The first one, the first to be the first. So which number that is greater than 2024? That is going to be the first one. So therefore, our n is going to be, just add 1, so it's 2000 and what, 25. So meaning to say, t 2025 is the first term that is less than what? T 2025 is the first term to be less than what? To be less than negative 20. It was negative 2020, 220, like that. So that is it. That is it. Just like that. Just like that. They'll be playing around with you guys. You see, exam need to prepare. But it was not that much. It was not that much on this question. It was just an issue of inequalities thereafter. And also knowing that x that you calculated before was very, very important. Question number 3, we are given a quadratic pattern is given. Determine the general term. Also, one of the direct questions when it is like this, because you just have to determine your difference is 0, 21, followed by 54, followed by 99, and so on and so on. This is a quadratic, and we need Tn for a quadratic in that form. All right, so already we're given the format. Whether you're given or you're not given, stages are simply the same. Gonna find our differences here, T1, T2, and so on and so on. So T2 minus T1, that is gonna give us 21. 54 minus 21, that was gonna give us, all right, so sorry for that. It's gonna be 33. All right, so you're gonna have 33. Okay, let me just have it here. Let me just have it here, guys. You see this thing? I had written this one down, you see now. So now I have to check to say, where is it that I wrote this? Okay, no problem. 33. 99 minus 54. 99 minus 54 is what? 45. Then the difference is, the second difference is 33 minus 21. 33 minus 21 was going to give us what? 12. So it's the same thing here, 12, like that. So you can find from here, since we are referring to Tn, we are going to need the value of A, B, and C. All right, so remember this is equivalent to 2A. We're just going to consider these terms. All right, so this is 2A, 3A plus what? 3A plus B, A plus B plus C. All right, so, all right, guys. You see this thing, I do not want when it is doing like this. When I'm about to write, all right? When I'm about to write, it starts to misbehave like this. All right, anyways, 2A is equal to what? To 12. All right, so we are going to consider in this case, all right, 2A is equal to 12. Sorry for that, guys. I did not see that my mic was off. So B is gonna be 21 minus what? Minus 3A, which is 21 minus 3 times 6, which is going to give us what? A 3. 21 minus 3 by what? 3 by 6. That was gonna give us a 3. So to find A, from A plus B plus C giving us the first term, our first term, that's a 0 there, as we are given, that was a 0. All right, so taking A, B, and C, I mean A and B, we can find our C. C is equal to 0 minus A minus B. So C is equal to 0 minus A is 6, minus B is equal to 3. So C was going to give us negative 9. All right, so therefore our Tn from Tn is equal to an squared plus bn plus c. That was going to be our a, which is 6n squared, b, that's 3n, plus c, which is what? Which is negative 9. All right, so let us just go through, guys, these questions and see where we do not understand. We shall try to have a recap if it is possible. All right, so that was it. Then which two consecutive terms of the first differences of this quadratic will have a quotient of 183 over 187? We have a quotient of 183 over 187. So in our case, we are given that they are from what? The first differences. We are supposed to work with first differences there. So as for you guys, do not worry about that. Let's worry about what? The first differences. The first differences they give us, this is part of a linear pattern, which is an arithmetic, this first differences. So you're just going to get rid of this quadratic, all right? This is the part of your first differences. The first differences. As we can see, there we have got a constant difference. So meaning to say the first difference is they're actually what? An arithmetic. All right. So using the Tn, because they're talking about which consecutive terms to say if the first term is n, the one that is following is going to be n plus 1. That is consecutive terms. All right. So we can use our Tn formula. Remember, I talked about this for an arithmetic. So that's Tn is equal to what? Tn is equal to a plus n minus 1 times d. Let's find it. So Tn is equal to a. The first term for these first differences, the first term becomes what? 21, followed by that like that. All right. So that is 21 plus n minus 1. All right, so that's going to be n minus 1 times d. Our d will be 12 because already, guys, these are the differences. You can see constant throughout. So this is 12. So you work from the first differences. You have got what? An arithmetic there. So this is it. With this, guys, we are going to find our Tn. Let's simplify it. Tn is equal to 21 plus multiplying by 12. That's going to be 12n times 12 here minus 12. So meaning to say Tn is equal to 12n, 21 minus 12. That is going to give us positive what? Positive 9. All right. So that's 12n plus what? Plus 9. This is our Tn from what we are given. All right. So if we are to consider this Tn, they said now to the statement that they gave us, they said if you have got Tn, another term is going to be Tn plus 1. So we have a quotient of. So the quotient that we are given there, it is simply telling us that it is the term before Tn over what? T of n minus 1, which is supposed to give us this. So as we've got Tn, the concept there is simply telling us that. Because, sorry, am I using n plus 1? N plus 1, not minus 1. Remember, the next term is what? N plus 1. This is equal to 183 over 187. This is what they're telling us. So Tn, we have it. This is our Tn. 12 n plus 9 over what? The Tn plus 1, meaning to say in place of n, put what? 12 plus 1. Put n plus 1. In place of what? In place of n, put n plus 1 like this. Tn plus 1, all right? Plus 9, the one that we already have. This is supposed to give us 183 over 187. We have formed an equation that we can use to solve for n. So how can we solve for n? From these two equations, from this equation, these two fractions that we have, let's simplify this one. That was going to be 12n plus 9 over what? Multiply by 12 is going to be 12n times 12 plus 12 plus 9. That's This one is going to give us what? 21. So that's 12n plus 21. If we simplify the denominator, that was going to be 12n plus what? 21, which is equal to 183 over 187. So we can simply cross multiply. 187 is going to multiply this part of what? All right, let me just write it. 187 multiplies everything in this part of 12n plus what? Plus 9. So that's 187 into what? Into 12n plus 9. This is equal to 183 multiplies what? 12n plus 21, just like that. So we are going to expand our brackets, then solve. We are done. So that is it. Times here by 187, we're going to have 2244 n. Then times 9 here, we are going to have 1683. That is equal to 183 multiplies 12. That was going to give us 2196 times n. Then we multiply 183 to 21. That was going to give us 384 3843. All right, so this is it. Collecting the like terms, we can take the n to one side of the equation. To the other side is going to be a negative 2244 minus 2196. It is going to give us 48. So that's 48n is equal to, taking the 1683 to the other side, is what it was going to be negative 1683, and that was going to give us 2160. So to find n, we can simply divide by what? By 48 both sides. Divide by 48 like this. So meaning to say our n was going to be equal to what? To 5. So we are considering to say that D, that is according to the value of n that we are given. When n is equal to 45, we are going to have the first one, because here we are considering the two terms, n and the other one being what? Being n plus 1. All right. So the question is which of the two terms, so the two consecutive first differences will be first one, n is what? So therefore, the first differences for n is equal to this. We must find that. And another one, n plus 1. That's 45 plus 1, which is what? 46. So in our case, they want the corresponding when n, because here they're saying which two consecutive terms. So when n is equal to what? 45. Remember Tn, where's our Tn? Here. Our Tn is 12n plus 1. This 12n plus 9. So that is where you're going to find the terms now from Tn, which is what? 12n plus what? That is sorry for that. 12n plus what? Plus 9. Yes, plus 9. Yes, that's it. Plus 9. That is it. Sorry for that, guys. That's plus 9. So for n is equal to 45, t 45 is equal to what? That is 12 times what? 45 plus what? Plus 9. And that was gonna give us 549 T46 according to what we are given there. It's going to be 12 times what? 46 plus 9, which is 561. All right. So meaning to say, according to what we have, the corresponding values are these ones. So that is 5, the consecutive first differences. All right. Which two consecutive terms of what? Of the first differences. All right, of the first differences. So that is these two terms. If we are to divide them, we are going to get that ratio. So you're talking about T45, which is equal to this. That's T45 and what? T46. Those are the consecutive. If we are to divide them here, let's see. T45, that is 5, 4, 9 like this, over what? The following one, which is T46, its value 5, 6, 1. We are going to have 183 over what? 187. Exactly what we are given before, to say that if we are to take those terms that we are given, the differences, we are going to obtain 183 over what? Over 187. So you must be very careful when answering your questions, all right? So that is from T46 to T45 and what? T46. In between, we are referring to these two corresponding 5, 4, 9 and what? And 5, 6, 1. And if we are to use on that ratio, we are going to have the what? The fraction that we are given, 183 over 187. So those are the two consecutive first differences. There will be first differences of what? Of the given sequence. There will be consecutive, this one followed by this one, from T45 and what? T46. So that was it. It's just a matter of more revision, doing more questions that can actually help. Question 3, which is we are given a quadratic. Why? I repeated this, all right? I repeated this question 4. Guys, what just happened? What just happened? Here it's like I mixed. Question 3, another question 3. But oh, it's just a repetition. Oh, it's just a repetition. Sorry for that. It's like now I was like, okay, did I take this from another question paper? Right? It's just a repetition. I repeated that question. A geometric series is given by 1 over 3 plus 1 over 9 plus 1 over 27. 4.1, is this geometric series convergent? Explain. So as a convergent, R is greater than -1 but less than 1 for it to be what? Convergent. So we must determine the value of R and see if it's gonna lie in this interval. All right, so R is equal to what? T2 over T1. This is T1, this is T2. So it's simply going to divide T2 1 over 9 over T1 1 over 3. So dividing this on your calculator, you're going to get 1 over 3. And truly, 1 over 3 is what? Less than 1. It is greater than 1. It is greater than this -1. So that is it, guys. All right, let us just consider another one. Express the above geometric series in what? Sigma notation. Remember, the sigma notation is simply tells us that if it is this condition of a convergent series, it means it sums up to infinity. So it sums up to what? To infinity. So meaning to say we can consider the sum to infinity. That is 4.2. The Sn is simply the sum to infinity for k starting at 1 up to infinity. But we must have the tk here. So tk is to be taken from where? From our terms that we are given. Remember, Tn is ar to the exponent of n minus 1. So Tn, a is the first term, 1 over 3. So that's 1 over 3 times our r. Remember, we got this one as what? 1 over 3 to the exponent of n minus 1. So we can put it back as it is like this, or you can just try to simplify it as we do understand. 1 over 3 is 3 to the exponent of -1. The same 1 over 3, 3 to the exponent of -1 raised to the exponent of n minus 1. So this is 3 to the exponent of -1 times expand by negative times n. That's 3 to the exponent of minus n. -1 times -1, that's a +1. So we are multiplying same bases. We can add our exponents. 3 to the exponent of -1 plus -n plus 1. -1 plus 1 cancels. We are left with what? minus n. So this is 3 to the exponent of what? Negative n. That's our Tn. So that is going to be our Tk. In place of n, we're going to use k there. So that was going to be 3 to the exponent of minus k, taken from 1 up to what? Up to infinity. That will be the sum of terms, all right? Just like that. Just like that, for 3 marks, we just had to determine our Tn. Simplification is very, very important. 4.5, we do not have something like that. This is question 5. The graph of f of x is sketched below. All right, this is the graph of our f of x, which is a hyperbola, given all right, the asymptotes, this and that. All right, so let us just see. This is our f. Sorry for that. This is our f. And there's also this piece here. And we're given the asymptotes. As we can see, one of the asymptotes that we are given here, x value, x is equal to minus 3. We do not have the one for y there, all right? But anyways, we are given the points A and B are the x and y intercepts respectively, okay? Then from the questions, write down the domain of what? The domain of f. Remember, the domain of a hyperbola, x cannot be equal to what? To minus 3, since it is an asymptote. All right, so that is x cannot be equal to minus 3, since it is what? An asymptote that we have. Determine the values of p and what? Q. To find p and q, all right, already there is an asymptote. We can play around with that one. This is our f of x. Let us just rewrite our f of x. So I'm just going to try to do it here. This is minus 3 over x plus p, all right, from what we are given on the original function of our f of x, all right, plus q. So that's plus p plus what? Plus q. If we check for the x-intercept, I mean for the asymptote, x is equal to minus 3. When you substitute back here, it will be a positive. So meaning you say automatically from this asymptote, p is equal to what? P is equal to 3. So that we can get x is equal to what? Minus 3. So that is p is what? 3. To find q, you can substitute back into the equation the p that we have. So it's going to be x plus 3 plus q. So you must determine q, this one. And that is the only unknown that you're going to have, because x and y can be replaced by what? A point, as long the point lies on what? On f. And that must be, sorry for that, that must be a complete one. Not just any point, but it must be complete. So we cannot use this because k is unknown. So we can use the point B, that is 0 minus 2. So using the point B, 0 minus 2, which lies on f, we've got x and y there. That is y is minus 2 when x is what? When x is equal to 0. So that's 0 plus 3 plus q. So minus 2 is equal to, simplify this, you're going to get minus 1 plus q. So to find this, add 1 both sides of your equation. So that is, we're going to have the value of q as what? Minus 1. All right, so q is negative 1. We're done. So this is it. The question was asking for p. So p is equal to 3. Q is equal to what? Q is equal to minus 1. All right, just like that. Just like that. So you can even replace them and have your equation. Remember, we said this is 3 and this is what? Minus 1. All right, so that will be our f of x in terms, in case we are going to need that one. All right, so moving on to another part, calculate the value of what? K. K is from the point A. Remember, A is what? The x-intercept, where y is equal to 0. Just substitute into the equation. So that's 5.3. To find k, it's a condition where y is equal to 0 at A. So that's 0 is equal to minus 3 over x plus 3 minus 1. Then we can solve for x. By solving for x, we are solving for k, that is x value. All right, so that is it. Add 1 both sides. That's 1 is equal to minus 3 over x plus 3. This is over 1. So we can cross multiply, and as we are multiplying by 1, guys, this is not going to change. It's just going to remain as x plus 3 equal to what? 1 times negative 3, that's negative 3. So to find x, subtract 3 both sides. So that's x is equal to what? Minus 6. So that is x, the value of k there. So therefore k is what? Minus 6. Just like that. Another question, for which values on 5.4, for which value or values of x will f of x be less than 0? Where is f of x less than 0? It means below the x-axis, all right? Remember here, it is negative what? Negative 6. It is negative 6 there. So they want us to have a condition where the function is below the x-axis, less than 0, guys, simply below what? The x-axis. Remember, y is equal to 0 in the x-axis. So where is it that our f of x is less than 0? That's our question 5.4. F of x, where is it found? Below the x-axis. All right, so according to our x-axis here, the first part, the first piece here is less than. It is below the x-axis. This region that we are seeing, it is what? Below the x-axis. So we are referring to which values in that case? Which values of x? Minus 6 going this side. X is supposed to be less than what? Minus 6. Or let's have another one. As we can see, from minus 6 going this side, these values, they are now above the x-axis. So we cannot take this one. At minus 3, if we check the other side, minus 3, talking about this, minus 2, minus 1, these values, the graph is below the x-axis. This is our x-axis, and our graph is what? Found below. This is exactly what we want. So from this minus 3, that is x is greater than what? Minus 3. The function that we have there is what? Below the x-axis. So meaning to say also x can be greater than what? Greater than minus 3. For these values of x, our graph is what? Below the x-axis. It is what? Less than 0. So that was it for 9 marks on this one. We are done. Moving on to question 6, which was given an exponential function. It is given by hx. All right, this is what you're given. Determine the value of h of minus 1. So guys, simply substitute h of minus 1 in place of x. Simply put what? A negative 1 in place of x. So that's 1 over 5 to the exponent of negative 1, and that's simply interchanging 5 over 1 to the exponent of what? Of 1, which is what? Which is 5. The moment you interchange what is inside the sign, it will be a positive. All right, so that's h of minus 1. Determine the equation of the inverse of h in this format. All right, so the inverse, as we can see that our h, it's an exponential, so that's 6.2. H of x can be written as y is equal to, in this case, y is equal to 1 over 5 to the exponent of x. So guys, I've talked about this type changing from a logarithm. Log a base b is equal to c. So therefore, a is equal to b to the exponent of c. So as we are changing back to the logarithm, since the exponent is going to be y there, all right? X is equal to 1 over 5 to the exponent of y the moment we interchange, and we want to make y the what? The subject of the formula. So that is going to be logarithm of a. Our a is what? Is x. A is equal to b to the exponent of c. So log a, that's log x in base b, base 1 over 5 is equal to c. Our c is what? Is y. So that is it in this format. So therefore, the inverse of what? Of x is equal to the logarithm of x in the base of what? In the base of 1 over 5. Just like that. Then you draw the neat graph of h and its inverse, all right, on the same set of axes. Indicate all critical features on the same axis, all right? So they never gave us any way to draw them. So just gonna use our sketch here. All right, so this is it. Remember our hx is given, so that's 6.3. We have our hx 1 over 5 to the exponent of x. It is a decreasing function that we have there. We are talking about a decreasing one. It's just like 5 to the exponent of negative 1x, all right? So it's going to be decreasing. I'm just going to put a sketch here, guys. Then you do whatever that you do to have the proper graph. So this is x, y, and we are limited for this 1 over 5 to the exponent of x at 0. When x is equal to 0, we're going to get a 1. Remember, any number to the power of 0 is what? It's 1. So it was going to be a decreasing function, all right, which crosses at a point where y is equal to 1. So we can find any other point along the graph, but it is not mentioned. They just want critical values, which is what? The y-intercept. So this is our h. And the inverse is a log function. Remember, the inverse is found by reflecting this graph in the line y is equal to x as we talk about the inverse. So we're going to have this side on the other side of what? The graph, all right? And this side on the other side of the graph. So it was going to be a decreasing one again for a logarithmic. So it was going to be something like this. All right, so that is it for the inverse of what? The inverse of h. Passing through the x-axis at 1. Remember, this one passes at 1 in the y-axis. This one is going to pass at 1. As you interchange or as you swap the coordinates, remember, reflection in the line y is equal to x. You just have to swap those. So that was it. You have got h and its inverse, just like that. All right, question 7. Given this compound angle formula, cos of A minus B is equal to cos A cos B plus sin A sin B. Use it. Use that one. Use the above. Use that one in that format to derive the specific formula for sine of 2A. So how can we apply or determine sine of 2A from a cos? Remember, there's a relationship between sine and a cos. Sine is equal to cos of 90 degrees minus x. A minus B, A minus B. This is what we want, A minus B. So this was going to be equal to cos 90 degrees minus 2A. But we do not have anything for 2A there. It is given A. There is no 2A there. So we must separate this A into two parts. 2A is same as what? A plus A. Remember that. So we want to properly see A and A separate. So this was going to be cos of what? 90 degrees minus A plus A to give us the 2A that we are given there. So this is going to give us cos of what? 90 degrees minus times minus. Minus times A, minus A, minus times A, minus A. It is just one and the same. All right. This simply gives us the minus 2A as before. So we just separated to see properly A and A so that we can separate one of these to be what? A. All right. So we must have minus, remember, cos A minus B. So we must have a negative. So to have a negative, we can take these two to be a single term. These two to be a single term. And this one will be on its own. So that is it. Once these two are representing these two are representing a single angle, and this one is representing a single angle as it is, we can use our identity. Cos A minus B gives us what? Cos of A, cos of B. So in our case, A is equal to what? 90 degrees minus A. Our B is the one that is represent A. So where we say cos A, cos B, our A, 90 degrees. So it was going to be cos of 90 degrees minus A times cos B, which is what? Our B represents A. So that's cos A. The sign, it changes if we check properly. Sorry for that. The sign here changes. Plus sine, sine. Sine A, sine B, plus. So we're going to add from what we just determined. We must have a plus. So this is going to be plus Sine of what? Our A, which is 90 degrees minus A. Sine of what? Sine of B, our B represents A. So this is it. We have applied that identity that they wanted you to use. And from there, you can use any other that you understand. Your core functions, cos 90 degrees minus A, this is a core function which changes to a what? To a sine. So it was going to be sine A there. That's sine. Is this A or B? All right, this is A. We just have A there. We do not have what? We do not have B. So this is going to change to sine A, cos A as it is. Remember, sine 90 degrees minus A changes to what? To cos. So it was going to be positive cos of A, sine of A. Are we seeing that these two are simply the same? So we simply have to add 1 plus 1, which is what? Which is 2. So that's 2 sine of A, cos of what? Of A. AB is the same as BA, remember. So and that's why I'm saying these two are simply the same. So it's going to give us 2 sine A, cos A. We are not given, are we given the answer? No, they did not give us the answer, but they said to derive the specific formula, this is the formula that you are going to have for sine of 2A, which we can also prove that it is the same sine 2 alpha. We can even check it from our formula sheet. That is sine 2 alpha is given. Remember, sine 2 alpha is what? 2 sine alpha cos alpha. So if it is A, this is A, this is A. And that is exactly what we are having here. So meaning to say we are done. That is the sine of 2A is supposed to be equal to this. Okay, so they'll play around with you guys, trying to confuse you by all means. All right, 7.2. If the sine of 45 cos 45 is equal to m, determine sine 330. All right, there's something about this sine 45, sine 45, cos 45. There's something about these two. All right, 7.2. The sine of 15, the sine of 15, cos of 15 is equal to m. There's something about this. Are we seeing they are just taking the double angle, but they did not put it all together because the double angle is supposed to be what? 2 sine alpha, 2 sine alpha, 2 sine alpha cos alpha. So if we consider that, put a 2, we must also do the same here. Remember, it's an equation. Whatever that you do on the left-hand side, do it on the right-hand side. So it simply means 2 sine 15 degrees cos 15 degrees is equal to 2m. So what does it mean? This can be written as a single trig, which is the trig of what? Sine 2 alpha. Sine 2 of what? Of alpha. Sine 2 alpha there. So if it is sine 2 alpha, it simply means sine 2 alpha like this. It's alpha is the angle that we have, which is 15 degrees, 15 degrees. So it was going to be sine of 2 times our alpha 15 degrees, which is what? 2 times 15, that is what? 30. So that's 30 degrees. So you're going to have sine 30 degrees. So we are simply saying, guys, sine 30 degrees is equal to what? Is equal to 2m. This is what we are given. Remember, you are given a single trig, but in this case, they try to avoid that single trig. Look for it. So if you are given this, it is just like we've got a new question now to say if sine 30 is equal to 2m, find or determine that in terms of m, sine 330. That is where now you can try to figure out, all right, what is it that I'm going to do from 330 that I'm given? All right, so to evaluate sine 330 degrees, 330, we can reduce it. It lies in the third quadrant between 270 and 360. So this is the angle for 360 minus what? Theta. So 360 minus what can be our theta for us to get 330 degrees. If we subtract this 360 minus 330, it was going to give us what? 30 degrees. So 360 minus 30, it gives us what? 330 degrees, meaning to say we can use the reduction as we have got what? The angle of 30 degrees there. All right, so sine 330 is the same as the sine 360 degrees minus 30 degrees in terms of what? The acute angle. So as we consider the quadrants, we saw that it is in the fourth quadrant, guys. 360 minus what? Minus theta lies in the fourth quadrant. And this is the quadrant for what? Cos, from the cast concept. So sine here is what? Negative. So it was going to give us a negative sign, all right? So that is the concept. That is the concept. So this is equal to a negative what? Sine of theta. Our theta is what? 30 degrees. Negative sine 30. And we have got sine 30 as what? 2m. So that's negative 2m. Just like that. We put back what represents what? The corresponding part of our sine. There was no need even for us to use the triangle, because it's sine to a sine. We are not looking for a cos unless if it was another angle. Yes, we can, but there was no need in this case. All right, so that is how you can attempt these questions. They wanted you to use the double angle in a hidden manner. They were trying to hide it. All right, so you had to figure out. Remember, it's an equation. Whatever that you do on the left hand side must be done on the right hand side, as long you do the same thing. Even let's say you wanted to add 1, as long you are forming something there, multiplying by 2, it is because we wanted to form this double angle. So the moment I take an equation, if it is sine x is equal to 1, the moment I multiply by 2, I'm also supposed to multiply by 2 there. The moment I divide by 3, also divide by 3. As long you do that, the equation is still the same. You haven't changed your equation, only that you are trying to rewrite it in a manner that you can work with it in a proper manner, or that you can solve it in a proper manner. So that was it, guys, for a total of what? 50 marks. I don't know. What do you think about this question paper? This test one that we had. As you can see, guys, we have dealt with different provinces. So you can judge with other provinces also. Take a look on other provinces and see how do they ask these questions. All right. Take a look also with other provinces and see how do they ask these questions, so that you compare. All right, you compare, you see that these questions, they are most likely to come in this format or in this manner. But if you check, guys, your questions, they repeat one and the same throughout. They repeat. Revise as many as you can. So that is it, guys, till we meet again.